So today what we're going to do, before we get into how you would actually calculate derivatives, we're going to do some work with estimating derivatives. So we're going to try to estimate derivatives at a point and use that to imagine what the graph of a derivative would look like. So here's a graph of a function, and in this window we have f of x. And over here, I would like to graph what the derivative of that function is. So over here, I would like to make a little sketch of what f prime looks like. I'm going to get a darker color here. Okay. And so here are some tricks for derivatives. I noticed that at the origin, there's a minimum value. And if I imagine sketching a tangent line that touches my graph at 0, 0, that tangent line would have a slope of 0. So that means on f prime, I would have a value of 0 at x equals 0. Okay, now moving along, if I have x equals 1, now I'm going to kind of roughly sketch what the tangent line would look like there. And that looks to me like it has a slope of about 2. It's not perfect, but I think at 1, the slope of the tangent line would be about 2. Now, if I go all the way to 4 and I try to sketch the slope of the tangent line, it's much steeper, right? So maybe at x equals 2, the slope of the tangent line is closer to 4. Oh, and then I noticed that with the parabola, this point and this point actually have the same slope, except this one would be downhill. So this would be -2, and then this point has the same slope as the one over there, except it's downhill, so that would have a slope of -4. So actually it looks like the f prime graph is a straight line. Now, I wouldn't expect you to be perfect, but I would expect you to for sure have your 0 correct. And I would expect you to say, oh, I noticed that in this quadrant, so for negative x's, sorry, I don't know why I drew a plus sign right there. So for negative x's, I know that my slopes are all downhill. So my parabola goes downhill. If I look at my graph of f prime, downhill, yeah, this is not downhill, but these y coordinates are below the x-axis. So as I do that translation in my head, the y coordinates here are negative, and the slopes on this one are downhill. The slopes on f are negative. I would also expect you to recognize that you're going to have a 0, a slope of 0 at the origin, because that is a minimum value, and you have a horizontal tangent line there. So I would expect your f prime graph to cross at the origin as well. And then I would expect you to recognize that on your graph, you then start moving uphill. So f prime would be above the x-axis at that point. Here's another one. I would like you to pause and just make kind of a rough sketch of what you think this one should look like. So knowing that you might not be perfect and it's okay to make mistakes, what do you think this graph would look like? Remember, this is a graph of f, and we're looking to make a graph of what does f prime, or the derivative of f, looks like. All of the y coordinates on f prime should represent the slopes of f. So go ahead and pause and try that. All right. I hope you tried it. What I notice as I look at this is that I have a couple of flat spots. So I should have horizontal tangent lines at about -1.5. So f prime should be 0 there. And it should also be 0 at positive about 1.5. And then I also notice that if I imagine this tangent line, really looks like it has a slope of 1 at x equals 0. So my tangent line, and it's uphill, so I'm going to have a value of 1 for the derivative. And here the slopes look like they're going downhill, so that means that before -1.5, my slope should be downhill. And so I should be below the x-axis. My slopes are not very steep, and then the steepest at -3. And it looks like, again, at -3, I see a slope of like -1. So I'm going to go here to -1, and I notice that the slopes are getting less steep. They're negative, their value's getting bigger, but they're steepness is less in the downhill direction. And so then I go up to 1 here, and then I go down here. I have a 0 here at about 1.5. And then my slopes are again downhill. So I'm going to go down here and make that curve. Maybe you recognize these two graphs. This looks a lot like sine of x, and this looks a lot like cosine of x. You don't have to worry about memorizing that fact yet. But as you're estimating derivatives from graphs, here's some strategies to keep in mind. First of all, look for maximums and minimums. If you have a horizontal tangent line there, your derivative would be 0. And then if you're trying to estimate a slope, go ahead and sketch a short tangent line to a curve. Just sketch it in and try to count rise over run. It might not be perfect, but it's a strategy. And then pay really close attention to uphill or downhill on your f of x function. That would mean that your f prime function would be positive if f is increasing, and if f is decreasing, f prime would be negative. So those are some really good strategies as you're looking at graphs and trying to sketch a picture of what f prime would look like. All right. The other time when you might need to estimate a derivative is when you're looking at a table. So here's a table. I've got a pot of tea that is, after a certain amount of time, the pot of tea temperature is taken. And it looks like the longer the pot of tea sits out, so as my time goes up, my temperature is going down. My tea is cooling off. And so I want to look at what is h prime of 3. I'm going to get a better color for drawing on this dark color. So if I want h prime of 3, I would like to do a slope, but I want some numbers that are close to 3. And looking at this table, the numbers that are closest to 3 are between 2 and 5. If I'm going to estimate with slope, I need 2 points, so I've circled those 2 points there. And then I need to do rise over run. So I'm going to do 52 minus 60. And then before I do the run, I'm going to look at what are my units for that. Well, my units for that would be degrees Celsius, because I'm on that y coordinate. And then I'm going to do 5 minus 2, and that's in minutes. So it looks like my units would be in degrees Celsius per minute. It's a rate of change, remember, of the temperature. So this would be negative 8/3 degrees Celsius per minute. Each minute, my pot of tea loses 8/3 of a degree, or 8/3 degrees, as it sits on the counter cooling off. So with tables, you want to use 2 good points, and you want to estimate using the slope formula. Points that are closer together provide a better estimate than points that are far apart. So I certainly could have used 0 and 9 to estimate the temperature of the pot of tea at 3, but why? That's not the best way to do it. The best way to do it is to find numbers that are close to 3 in my table. Often I see the College Board giving credit for showing this kind of work, and it is not uncommon for them to ask for units. Just a word of advice about the AP test and in general. They don't give you points for saying units if they haven't asked for them, but if they have asked for units, they definitely expect to see units and will take points off if you don't give units.